Thank you, everybody, for your participation in the first session. I am happy now to hand it off to Dr. Anastasia Loukaitou-Sideris, who is a distinguished professor of urban planning and the associate dean at the Luskin School of Public Affairs at UCLA. She's done a lot of work in a lot of different areas. I'm most familiar with what she's done on sort of user perspective and interaction with the built environment. She has strong connections to at least two, as far as I know, of the PSR consortium institutions. In addition to being at UCLA, she is a graduate of the PhD program in urban and regional planning at USC. And I think, Anastasia, you completed just when I was going through the program, and I first became familiar with your work with Dr. Banerjee. So I know that Metrans and PSR are thrilled to have you take part today. So I'll hand it off to you.
Well, thank you very much, Tom. Thank you for inviting me to be a discussant in a session that I think it's going to be very interesting. As you know, this is the fourth session of the conference, and it is focused on mobility. And I think we all know that transit ridership has started taking quite a dip in Southern California before the pandemic, and of course, even larger dip during the pandemic, but that's a phenomenon that it is around the US. And there are a number of reasons behind why this dip is occurring. And some of these reasons may be sociodemographic changes in the neighborhoods. Some of these reasons may relate to increased automobile ownership or the emergence of new and different transportation options that consumers might have. So this session has two great presentations that explore some of these questions. So I'm going to introduce first the first presenter, and after her discussion, I'm going to introduce the next presenter. But the first presentation is from Hannah King, and she asks, has transit ridership decreased because transit accessibility was diminished for people who used to live near transit-rich neighborhoods, but now have been forced to move elsewhere because of gentrification and displacement? I think it's a very interesting question. And Hannah is a doctoral student at my own institution at UCLA. She's a transportation planning student. Prior to coming to UCLA, she had spent several years looking into sea level rise and economic development planning projects at the state of Florida. Her current research interests center on active transportation, GIS, and transportation financing. And her advisor is Professor Brian Taylor. Hannah's presentation is Neighborhood Change and Travel Behavior in California's Transit-Rich Neighborhood. And so I'm asking Hannah to take the next 15 to 20 minutes presenting her talk.
Good morning, everyone, and thank you for being here. And thank you, Dr. Loukaitou-Sideris, for the introduction. Appreciate it. So I'm Hannah King, currently a fourth-year transportation planning and policy student at UCLA. And I'm here today to talk a little bit, like Dr. Loukaitou-Sideris, about some research I'm currently doing with Professor Evelyn Blumenberg of UCLA, about neighborhood change and travel behavior in California's transit-rich neighborhoods. Full disclosure, this isn't technically my dissertation research. Let's call it like my pre-dissertation research. But the themes that I will be addressing in my dissertation research will be very similar and build off the same data set and questions that I'm asking. So let's get into it. For today's presentation, I'm going to keep it standard and try to keep it short and snappy. Start out with a little bit of background and motivation, talk about data and research methods, discuss some very preliminary results, and end on touching on the future work that I hope and will be doing with this work. So next couple of slides, I'm going to get more into these, but just briefly, why I'm interested in this topic and why work in this area is valuable. First, as we just heard, transit ridership in California and in the U.S. as a whole has been falling for years, and COVID-19 has only exacerbated those existing trends. Second, commute distances are increasing. And I'm glad that little conversation before this session is very sort of indicative of that. And third, as anyone who has been on the housing market in California, or really any big and or coastal cities in the U.S. in recent years can attest, housing prices have gone up a lot. And with rising housing prices come the risk of gentrification. So to get into it. Like I said, transit ridership is down in California and nationally. This graphic comes from a report that I was a co-author on, came out last year. It's on the UCLA ITS website if you want to check it out. But what it shows is just change in transit ridership since 2008. And what we see is that ridership down in California and the U.S., but it's down more so in California. And this really steep decline that we see in California is largely driven by trends in the Los Angeles region, just because transit ridership in the region is so large, and it constitutes such a large portion of the state's total. Until fairly recently, or more recently, ridership in San Francisco has held up better, really thanks to BART, but even that has seen some significant ridership declines in recent years. And this is not the subject of the presentation, but it's an obvious question. COVID-19 really has not helped ridership. This comes from a report that the local government, Southern California Association of Governments, put out in August of last year. And what it shows is that when the pandemic hit, when everything shut down, but just about a year ago now, ridership kind of took a nosedive, what was already a secular decline trend. And I don't have more recent data in front of me. I'm led to believe that ridership has recovered somewhat, but it's still below what it would normally be. So this graph is actually for another project I'm working on, looking at transit ridership declines. And details aren't important, but what it shows are just ridership gains and losses in LA from 2008 to 2018. Red, bigger losses. And what this shows is that, transit is inherently an asymmetric phenomenon. Most transit ridership is concentrated among a relatively few amount of riders on a relatively small amount of the land area. And in LA, how this has played out is that we've seen really significant ridership losses along the heavy rail lines. And part of that is just because to have really high ridership losses, you have to have a lot of ridership to begin with. But the fact that the best quality transit service in the county is losing ridership is concerning. And what we've seen is that increases are really only occurring where we've increased service. And from an operator standpoint, that's not ideal. Okay, just to switch gears a little bit, talk about commute distances. I'm not going to spend too much time on this slide, except to say that what this shows it's two versions looking at the same data. Right is just the mean, or left is just the means, right is just the medians. And it looks like commute distance increases by income category. Low income on the left, higher income on the right. Two things to note. One, commute distances are up pretty significantly since the turn of the century. And higher income people have longer commutes than lower income people. And I won't get into it, but that's what the literature would predict. This is national data. This in California, this comes from another report that ITS put out looking at transit ridership in California. What it shows, again, not going to spend too much time getting into the numbers here, but what we see if you look at the bottom, that change in commute distance, both the median and median are about 1.5 miles from 2002 to 2015. So just in like under 15 years, we've seen commutes increase a pretty substantial amount. Housing costs in California have increased substantially in recent years. And so I just pulled some census data. It's at the tract level. This is adjusted for inflation. But just in the 13 years between 2002 and 2015, we saw median housing values increase $200,000. which is a lot. And again, this is in real terms, so that is accounting for the effect of inflation. And I don't have the rental data in front of me, unfortunately, but we see similar sort of dramatic increases in rental prices there as well. And this is where sort of the obligation of transportation professionals to be mindful of sort of what effect like current policies are having comes in, because ultimately when we do see these large increases in housing prices, that raises questions about, okay, who can afford to live in what neighborhoods? And to the extent that these housing cost increases are going, and they will disproportionately impact low-income communities, particularly low-income communities of color, it's incumbent upon scholars and policymakers and planners to try to understand how these housing markets might be driving, again, it's often racialized processes in neighborhood change. Okay, so kind of putting all of this together. In this particular project, Professor Blumenberg and I are trying to think about what is this relationship of growing commute distances to declining but spatially concentrated transit ridership and increasing housing costs. Increasing housing costs, again, as a way of understanding how these neighborhoods are changing with respect to income and race. So the data for this, it comes from sources I use a lot, the American Community Survey, the Access Observatory data from the University of Minnesota, which is great, and it gives job access by transit. And finally, another data set I've worked with a lot, job worker and commute data from the 2015 Longitudinal Employer Household Dynamics or Destination Employment Statistics, or LODES. It's a very, very pithy data set name. So for this particular project, we're not doing anything too fancy on the empirical side. Doing basic descriptive analysis, leading into simple linear regression with commute distance as a function of these housing market conditions, demographics, job worker characteristics, and transit supply and use. And I'll get more into this in a little bit, but actually I'll get into it now. So we're looking at data at the census tract level, and a census tract is about 4,000 people, and we're looking at data at the census tract level for two reasons. First is that it's commonly used in the research, about 4,000 people, and so it approximates the neighborhood. But two, and probably more importantly, we have data at the tract level. But the fact that we're using tract level data raises a problem. Sort of tract boundaries are inherently arbitrary. And so we need to use spatial methods to kind of control for any kind of issues that these sort of arbitrary groupings of data might be introducing. And that is, I'm not talking about that today, but that will be something we're working on. So again, linear regression, log of commute distance as a response variable, basic data transformations to make linear regression more appropriate. We're specifically looking at commute distance from the worker residence, which conceptually is different from looking at commute distance from the work site, just because most people don't live and work in the same neighborhood. And so it's a data grouping problem. So anyway, specifically modeling commute distance from the home site as a function of employed residential density, doing that to control for basically population size, looking at the availability of affordable housing specifically for low-wage workers, although we do want to extend that to all workers eventually, looking at the number of low-wage workers, controlling for vehicle ownership, just because if you have access to a car, it's probably easier to drive further, looking at the number of Black, Asian, Hispanic workers, get at those race effects, looking at job access by transit, living in an area that is an employment center, and if anyone is interested, I can get into the weeds in the Q&A, but basically we have other ongoing work that suggests that if you live in an area where there's lots of jobs concentrated, that probably has an effect on commute distance. Also controlling for proximity to a rail station and being in a major metro area. And I'm not going to spend too much time getting into the weeds on the descriptives. But what this shows, this is just basic descriptives by region. 3 columns. First is the different regions. Middle is the entire region. And then on the right, it's just transit-rich tracts. And by transit-rich tracts, I just mean it's in the top 10% of transit service in each region. Although we look, so it's the binary definition of transit access, but in the regressions where we look at both binary and continuous measures, and the results aren't sensitive to how we conceptualize it. But the top chart just shows that, sort of by definition, these transit-rich tracts have much better transit access, which is good because that's how we define them. The bottom chart is a little bit more interesting. It looks at median commute distances. And the thing to note here is that commute distances in transit-rich tracts are a lot shorter than they are overall, particularly in San Francisco. The top chart, it looks at just percent non-Hispanic white. And if you compare the numbers, 4 out of 5 of our regions are less white in these transit-rich tracts, except for San Francisco. San Francisco is actually more white in these transit-rich tracts, and that probably, I suspect, has a lot to do with downtown San Francisco. Very, very dense, very expensive, and has a very high-quality transit system. At the bottom, looking at median percent Hispanic, little bit more mixed here. But for 3 of 5 of our regions, the transit-rich tracts are more Hispanic, and then for 2 of them, including San Francisco, they're less Hispanic. The other being San Diego. If we look at poverty, the story here is a little less ambiguous. Transit-rich tracts are across the board have much higher levels of poverty than the region as a whole. And it's actually San Francisco has the lowest level of poverty in its transit-rich tracts, though. And then on bottom, we look at vehicle ownership, which is really just another way of looking at income, because most people who don't have a car are low income. These transit-rich tracts, that's rates of not. Basically, if you don't have a car, you're probably going to locate in these transit-rich tracts to the extent that you can. And so, yeah, in San Francisco, where there's higher quality transit in a bigger area, that we see that difference is bigger than it is elsewhere. Okay. And then both of these are just different ways of looking at size. It's just jobs and employed residents per square mile. Again, same thing we see across all 5 of our areas is that these transit-rich areas are much denser than the region overall, which is exactly what we would expect. Transit works best in very dense areas where we have lots of people and lots of places to take them in a short amount of space, so it makes sense that the places with best transit service are very, very dense. And then finally, looking at a measure of jobs to residents, which is exactly what it sounds, just the number of jobs divided by number of residents. And I got to do that. And the thing to note here is that that ratio is a lot higher in transit-rich areas, which just means that there's more competition for available housing units in those transit-rich areas. Regression results, I'm going to skip ahead. The thing to note here is that everything behaves like theory would pretty much predict. In findings, high level, transit-rich areas do seem to be distinct from other areas, particularly in San Francisco. Commute distances are higher. We have more competition for affordable housing units. Tracts with more Black and that should be non-Hispanic, Black, and Hispanic employed residents. Commute distance are higher when we have higher levels of vehicle ownership in San Francisco and in rural areas. Conversely, commute distances are lower in dense areas that have larger numbers of low-wage employed residents in areas with better transit supply, near rail or employment centers, and in San Jose. So current conclusions, again, this is a very much a work in progress, but basically transit-rich areas are distinct in the ways that I and literature would suggest that they would be. But there is something different about San Francisco. And it does seem that competition for affordable housing is related to commute distances. And even though this current analysis, we haven't gotten to a really refined gentrification analysis, even controlling for economic factors and transit proximity, race and ethnicity matter. And that suggests there is something racialized going on that we need to get at. And there's a lot of things I want to do, but I'm out of time. So, thank you for paying attention. Oh, and last thing, thank you to everyone at UCLA. They're all great. The faculty I work with, Brian Taylor, Edward Blumenberg, Mike Manville, Marty Wax, UCLA students and former students I've had the privilege to work with. My work builds off what they're doing and what we've done together in so many ways. And so I can't not thank them, as well as the ITS staff, who, without them, I would be running around like a chicken with my head cut off. They're great. So anyway, thank you so much for paying attention.
Thank you very much, Hannah. I see we already have one question that I can read it to you. It says, what are the practical consequences of your research within an ontological aspect which discovers a choice of the research problem? In other words, dispensation of contradiction between mobility opportunity and ability for designing of a behavior strategy. Thank you.
Yeah, Alessia, would you be able to just speak to your question a little more? Just kind of expand on what you'd like me to get at.
Maybe what are the main practical results of your research to all of us?
Okay, yeah, that's a really great question, particularly because I do come from the policy space, so application is kind of what I'm here for. I think one thing is that again, transit ridership has been going down, and I kind of suspect, based on some data, but that part of what we're seeing are the long-term consequences of operators' decisions to make sort of service improvements that try to emphasize what we call choice riders, the sort of higher income folks who have a choice to use transit. And that means investing in things like high-speed rail or commuter rail rather than the workhorse of transit, which is really local bus service. And by sort of disproportionately emphasizing these investments that are aimed at like increasing, again, that's what we call this choice ridership, we've kind of abandoned the really loyal low-income riders who, by the way, are more dependent on transit. And what this means in the context of automobility becoming less expensive, credit being easier to obtain for car loans and things like that, is that people at the lower end of the income spectrum have every incentive in the world to jump ship as soon as they can, get a car. And of course, like urban design already makes it really beneficial to own a vehicle. So this is only contributing to the marginal benefit of having a car. And so it's this like self-perpetuating cycle where you make suboptimal investments from just a management standpoint, and that just leads to declining ridership, and you get into this death spiral. And I think, it's like, this is why it's like from an operational standpoint, very important to not forget the needs of like your core client base. And yeah, again, it's choices that we've made, and now we're sort of reaping the consequences of that. And then, yeah, so just the racial politics involved in like these transit policy choices. Yeah, just not forgetting about that.
Okay, there is one more question, and I want to combine it with one of mine that I wanted to ask you. So this question asks about what are your policy recommendations, especially related to affordable housing in transit-rich areas? And my question is, we have found with Karen Chappell, looking into both Northern and Southern California, that census tracts that have a transit station were more likely to gentrify than those that have not. So again, what are the implications of that? Does it mean that, we're building new developments around transit stations that help gentrify the areas, and based on your findings, these people do not use transit? So what are the implications of your work for building affordable housing in transit-oriented neighborhoods?
Yeah, I'm going to channel Mike Manville here and just say, like, really the fundamental problem is we just don't build enough housing. So the conversation, so that's where I would start. I think overall we need to start with zoning reform, that it just allows us to build more. And that's not like a panacea for everything, but that's a good place to start. It just opening up the real estate markets, which puts so much pressure on these these multi-family units that are really largely only available in your transit infrastructure. Because my understanding of the literature is that a lot of people are choosing to purchase into TOD, not because they want to use transit necessarily, but because they like walkability, because they want to live in a multi-family unit, because they want something smaller. And so if you just open up the real estate markets a little bit, that helps with this problem.
Thank you very much, Hannah, for our second presentation. And this presentation is going to be given by Farzana Khatun. I hope I haven't mispronounced your name. Oh. And basically she asks, has transit ridership declined because other travel options have emerged, namely ride-hailing? Companies like the Ubers and Lyfts of the world have taken a share of riders from transit. And so Farzana is a fifth-year PhD candidate in the Transportation Science program at ITS at UCI. Her research interests include transit, transportation network services, travel behavior, GIS application in transportation planning, and econometric modeling. And she was the winner, the PhD winner of the Women Transportation of Orange County Scholarship in 2019. Her advisor is Professor Jean-Daniel Saforis. And the title of her presentation is Are TNCs Eating Transit's Lunch? Evidence from the US National Household Travel Surveys of 2009 and 2017.
Good afternoon, everyone. I hope everyone is doing well. Very tough time for all of us. So today I'm going to talk about TNC, transportation network companies who operate Uber and Lyft, and transit. These are two of the major components of my PhD dissertation, as well as my PhD, the projects that I'm working on. To be more specific, today in this presentation, I will try to figure out that whether TNCs has an impact on transit use. Now, going into detail, before going into detail, I like to provide you some background, why I have come up with such idea. I have tried to put the situation of TNC's growth and transit growth over the last decades with some regional and statewide statistics. In this part of of the pyramid, as you can see, I put the TNC's growth, and in this part is the transit's growth over the last decade. Now, we all know the TNC started somewhere in 2009, and afterwards there were no stopping them. This industry was booming, at least before the pandemic, we can say that. And following its success in 2014, TNC's transportation network companies incorporated Uber, Pool, and Lyft into their services. And by 2016, they served almost 170 metropolitan areas. And by 2017, TNC transported 2.61 billion passengers, which is almost a 37% increase the year before. Now, San Francisco alone carried 75 million of those trips. So as you can see, this industry is booming. Now, let's shift to the right side and have a look into what's going on almost over the same time period with the transit. When TNCs is increasing, there are like concern raised about this new services like VMT increases. It probably has an impact on the transit as well. So looking at the transit statistics, if you see the transit ridership in one word, it's falling. So if you look at one statistics between 2011 and 2017, USA bus transit agencies collectively lost almost 9.36% of their passengers' miles traveled. Now, if you look at statewide statistics, if you consider California lost almost 62.2 million annual riders between 2012 and 16. Now, these ridership is falling despite the investment in transit to curb congestion is increasing. I provided a statistics from California. Between 2000 and 2015, the public investment in transit increased by 50%, but alas, the ridership is still decreasing. Now, people talk about many reasons that why this ridership is decreasing. There can be numerous reasons. Car ownership, transit service decreased, or maybe somehow this booming industry like TNCs have an impact on this ridership falling. Now, this is where I dived in and tried to figure out that whether TNCs are working as a negative reinforcement for the transit falling ridership. This is, before going to the objectives, I like to tell that in my previous ESTRS symposium, what I did, I used 2017 NHTS database, and I tried to characterize and contrast transit and TNC users who are taking both and where do they live. I'm not going into detail into that one. Why I can talk about it if you have any question after my presentation. Why I showed it over here, it's because of the data in the sample. So I used 2017 sample households who had access to both TNCs and transit, and I figured out who are the transit users. Now, in today's symposium, what I'm trying to figure out that these households, due to the TNC's penetration in the market, making less amount of transit trips, or what is happening with the travel behaviors inside their household. That is the things, that is the current objective of my today's presentation. So what I tried to develop a conceptual framework over here. Now, before that, let's think in this way. I am Farzana. I am in 2017. So I have access to TNC. So somehow TNC's penetration in the market have an impact on my travel behavior. Now you can, and NHTS has collected my data in 2017. Now you can see, you can tell that, okay, TNC, Farzana is using TNC. So what about what TNCs were not there, what she was doing? Is it possible to evaluate how TNC has impacted her travel behavior? This is actually possible. So how this is possible? You need to create a pseudo Farzana. What does pseudo Farzana means? So that means exactly not me, someone who shares similar characteristics like me, but only difference that will be she will not have the access to TNCs, and she has to be in, suppose like 2009. Luckily, in 2009, this pseudo-Farzana's travel behavior was captured by the NHTS 2009. So why I am giving this example, it's because, as you can see, here are 3 red highlighted points that I like to mention. So there are treatment effects, covariates, and outcome variables. Treatment indicators means treatment group who had access to TNC. Like I said, this is me, Farzana, who belongs to 2017 households, and these databases are available in the National Household Travel Survey. Now, here the control group, who is like a pseudo Farzana, who does not have access to TNC, but these 2 groups share similar kinds of characteristics in terms of this kind of variables. Suppose like they have similar kind of household and socioeconomic characteristics. They live in the same MSA metropolitan statistic area. Probably they have to pay like same gasoline price and congestion prices. Now, when we create these 2 group of people and bring them in the same platform, we can actually compare their travel behavior, even though one of them did not have access to TNC and the other one have access to TNC. And after doing that, you can think about how their total number of transit trips differ between these 2 group of people, how the total distance mile travel differ between these 2 groups, and so on and so forth. Now, this is the overall conceptual framework. The ultimate goal is, based on these covariates, you need to create this 2 group of people so that you can differentiate their travel behavior. Moving on, in order to achieve that conceptual framework, we use propensity score matching. Now, what does propensity score matching do? Propensity score matching is simply running a logic model based on the covariates that I just showed and calculate the probability. This probability will be considered as a propensity score. Based on Farzana's propensity score, you will also calculate the propensity scores for the pseudo Farzana, and you are going to match them. And that is where propensity score matching comes. And after the matching, what you will do, when you have the treatment group and control group variables in the same platform, you are going to calculate the treatment impacts. Treatment is here, just to remind you, the penetration of TNC in the US market and how this penetration has an impact on your total transit trips inside the household, total distance travel, on total time travel. And these are some of the equations that we need to use to estimate these impacts. Now, one thing I like to mention here, the beauty of PSM, propensity score matching, is that other than the TNC's impact, the control group and treatment group household would not have much differences in their socioeconomic characteristics, land use variables, and the other variables that I used in my conceptual framework. That means we can, by using PSM, we can discard the self-selection bias from our modeling approach. So moving forward, these are my model covariates. As I have shown in my conceptual framework, that I have certain amount of covariates which I use to match my control and treatment group households. Here, as you can see, only the congestion variable is not collected from the 2009 NHTA, 2009 and 17 NHTAs. Otherwise, all the socioeconomic, gasoline price, and land use variables are coming from these 2 sources. The congestion variable I collected from Urban Mobility Report, which is published by Texas A&M Transportation Institute. And what I did, I associated this variable with my NHTS variable based on the MSA, Metropolitan Statistical Area, because these 2 reports have information about the Metropolitan Statistical Area. Now, let's give you a claims about how I process my data. As you can see, there are lots of things going on in the conceptual framework. I have to create treatment group, control group variable, then I have to match them, then I have to merge them, lots of things going on. So I will try to give you a small glimpse how I did it. So first, I extracted the socioeconomic tree related information, gasoline price information from 2009 and 2017 NHTS database. In this way, I came up with almost 79,000 control group households from 2009 database and almost 22,000 households to 2007, which are treated as a treatment group from 2017 NHTA. Just to give you a reminder, these households had access to TNC, and these households did not have any access to TNC. Now, in the second step, as I have two different data sets, I have to append them and created a unique variable which defines that which observation are coming from which year. In this way, I ended up having almost around 100,000 households data. And finally, my target was to add the congestion variable with these households data. So when I added the congestion variable based on metropolitan statistical area, my final sample sum stands for almost 86,000 households, where 66,000 households represents control group households, and almost 20,000 households represents the treatment group households. So just to clarify one thing, before you can report the results from the propensity score matching, you have to make sure that there are no differences in the covariates that you have selected to match them between the control and treatment group household, other than only the impact from the treatment, which is TNC's penetration in the US market. Now, you can actually have a diagnosis of this condition. This is called condition of independent assumption. And in order to do that, what you need to do, you need to calculate the mean difference of those covariates before and after matching. As you can see, the mean bias before and after matching has reduced. There is still some bias, but study says that if this bias after matching is less than 10%, then you are good to go with your sample size to get the treatment effects. And I just like to clarify one thing. Sorry, I did not mention it earlier. When I tried to figure out how the travel behavior of the households between 2009 and 2017 varies, I tried to develop three models. One is overall USA, one is for the weekdays, and one is for the weekends, just to see that whether weekends rate is higher or lower. How does the weekend rate varies compared to the weekdays travel behavior? So here are the results of my analysis. A quick recap. My treatment is TNC's penetration in the USA market and how it has an impact on transit use. And you should remember one thing, that the covariates or coefficient value that you are going to observe here is attached to the treatment of the treated. Treated means those who had access to TNCs in 2017. That's why this is saying in over there, I have only provided the 2017 household with access to both TNCs and transit. Now, what I started my hypothesis that yes, there might be a chance that TNC has a negative impact on household travel behavior, especially transit use. It turned out that actually TNC had a negative impact on transit use of the households. Per day per household in overall USA almost made 13% fewer transit trips compared to in 2017 compared to in 2009. Now, this rate is higher in weekdays with 16% decrease in transit use, and weekend is 12% decrease. So these three are almost significant. Now, when it turned out TNCs has an impact on transit, people are making fewer transit because of the availability on train set, it has some unintended consequences as well. I tried to look into what is happening with the other trip attributes, like what is going on inside the household about in terms of their walk trains and drive trains. It turned out that people households in 2017 is making more walk trips and bike trips compared to 2009 households due to the penetration of TNCs in the US market. Moving forward, as I have told earlier, that other than the TNC use, I have also seen that how TNC has an impact on households' total distance travel and total duration travel. Interestingly, as you can see, even though interestingly, you can see that the households in 2017 are making less, are traveling less miles compared to the household in 2009. Now you can act
2 more minutes, okay?
Okay, I'm almost done. Yeah.
Great.
So if you move forward, if you try to relate this kind of findings with the transit trips, making fewer amount of transit trips, you can find a connection. You know, when you make a transit trips, you usually go longer distance because you cannot take a detour, and also you have to go for several transfers as well, which you don't need to do it when you have a TNC. Through TNC, you can actually take detour. You don't have to go for a longer distance. Probably this is one of the reasons that the travel distance is, people are traveling less amount of distance compared to 2009. Now, if you look in the travel duration, even though travel distance decreased, the travel duration increased. Now, what I tried to connect, that one of the reason is, if you look into the TTI congestion report that I collected from urban mobility, I tried to create some box plots based on different metropolitan statistical area size of between 2009 and 2017. It turned out that compared to 2009, on an average, actually the congestion rate in 2017 in most of these areas, almost all in the different size of metropolitan statistical areas, got increased. So these can be a reason, even though the travel distance is decreasing, the travel duration is increased in 2017 for 2017 household compared to 2009 households. Now, I'm almost done. So one of the things that policy implication wise, which is very important, transit agencies are trying to make contracts with the TNC to provide first and last mile services. So far I have worked with two things. One, figuring out who are the TNC users and how their characteristics differ from the transit, and also how TNC has an impact on the transit use. These findings of my study, as you can see, that people are making fewer transit trips due to TNC, provide some valuable insight for the transit organization, how they should actually have a contract with the TNCs. One of the limitations of my study is that other than the external factors, something has happened between 2009 and 17 inside the transit agencies, like transit supply wise. I could not capture it because I am working with very micro level a unit of analysis, which is household, and these variables are available at a more aggregate level. But this is something I would like to do in future, so I can see that whether the percentage that I've shown, if I take into account what happened inside the transit agency between these years, then probably the rate can be changed. That is all from my end. Thank you very much for listening to my presentation.
Okay, thank you, Hannah, very much. I don't see any questions. Any questions for Hannah? I mean, sorry, for Farzana. I'm very sorry.
No problem.
I have a question, and as we're waiting for maybe others to add, can you tell us at this point which particular group is more likely to switch from transit to TNCs in terms of age or in terms of socio-demographic characteristics?
I have figured this out in my the previous study that I have worked with. This is I developed a cross-nested logit model. I can tell you that there is a tendency of the millennials, if you consider the generation-wise impact, who live in a densely populated area and who have like different options mobility options available, there is a high chance this group of people may transfer from transit to TNC. And I can provide you a perfect example through me. I don't know how to drive. I don't have a car. So I'm living here almost 5 years. At the very beginning, I was using transit in the Orange County. As you know that these are not in a very favorable condition. So I moved back from transit in using TNC because it was more flexible options. It was providing me more flexible options. That I can tell you.
It would be very nice to also add a slide that shows who are the likely transit users, and see if there are any overlaps. But these are, I think, would be interesting information for transit agencies to find out which particular sociodemographic group is more likely to be attracted. And you already responded. You are saying the millennials. And I assume that certain types of millennials, maybe those that do not own cars, that are probably of lower income, etc. But it would be a kind of this more targeted research would be extremely interesting, I would think. Yeah.
Thank you. Yes. Yeah.
Okay. I think I don't see any other questions, and we are coming to the close of this session. I thought these were two very interesting presentations that help us partly respond to what led to this dip in transit, and I'm pretty sure that policymakers and transit planners would be very interested in these results.